Okay, the next lesson we're going to be solving a quadratic using the quadratic formula, but we're going to also talk about what just the discriminant part of the quadratic formula means for a moment before we get into solving completely. So the discriminant can tell you how many real and imaginary solutions a quadratic can have by its value. So if we get a positive number for the discriminant, which the discriminant is just this expression b squared minus 4ac. So if we get a number that is positive, greater than 0, then we know that the equation is going to have two real solutions, which means the parabola is going to hit the x-axis in two spots. Okay, so that's if the discriminant's positive. If the discriminant is equal to 0, then we're only going to get one real solution, which means that the vertex of the parabola is just going to hit in one spot. So we're not going to get 2 points of intersection on that x-axis. We're just going to get one. Okay, so that's if the discriminant equals 0. And then our third case is when the discriminant is negative or less than 0. And that means that we're going to have imaginary or complex solutions. Graphically, that's when the parabola will not touch the axis at all, right? It's completely above the x-axis or completely below the x-axis if it opens down. So if we get a negative discriminant, we know that there's going to be two imaginary solutions. Okay, we can also get rational solutions, so meaning whole numbers, or we could get irrational solutions. So those could be simplified square roots, so ones that don't come out as whole numbers. So we're going to practice finding some discriminants and kind of analyzing what type of solution we are going to have. So the first example says 9x squared minus 3x minus 8 equals negative 10. The first thing that we have to remember is that these quadratic equations must be in standard form. So ax squared plus bx plus c equals 0. So no matter what, we need to isolate the variables and the constants on one side of the equation. So this in standard form would be 9x squared minus 3x plus 2 equals 0. Now I can identify the A, the B, and the C. So the discriminant is b squared minus 4 times A times C. So if I locate those values in this quadratic equation, my B is negative 3 minus 4 times A, which is 9, times C, which is 2. So if I simplify that, order of operations, super important here. Negative 3 squared is positive 9. I would not subtract next, but multiply all of these values together. So the 9, or the 4 times the 9 times the 2. So 4 times 9 is 36. 36 times 2 is 72. And so then we complete the subtraction last. So I have 9 minus 72, which 9 minus 72 is going to be a negative number, specifically negative 63, if I were to do that math. But the fact that it's a negative number is going to tell me how many solutions it has, right? If we think about it, right, the value of the discriminant is going to be underneath a square root sign in the quadratic formula, which I know we haven't even said what the entire quadratic formula says yet, but you're going to be square rooting this discriminant when you do the quadratic formula. So the fact that it's a negative number means that I'm going to have imaginary solutions. So this parabola is not going to touch the x-axis at all. And then if I think about taking the square root of 63, the 63 is not a perfect square. So I am going to have an answer that has a square root in it. So it's going to be an irrational imaginary number. Okay, number 2. Again, getting it in the right form, I'm going to add 6 to both sides of that equation. That's going to give me negative 2x squared minus 8x minus 8 equals 0. We also would like the lead coefficient to always be positive. So I'm going to multiply through everything by just -1. All that's going to do is it's going to change all of the signs. So anything that was negative becomes positive. Anything that would have been positive, which I don't have any positives in this equation, but if there were positives, they would turn into negatives. So just multiplying through by a -1. Now, if I evaluate that discriminant, b squared, that's 8 squared, minus 4 times a times c. Order of operations, 8 squared is 64. 8 times 2 is 8, times another 8 is 64, and we are subtracting. I get 0. So again, taking the square root of 0 is just going to be 0. I'm going to get one real solution out. So it's going to, that tells me that it hits, the parabola hits in one spot. And I can take the square root of 0, so it is going to be a rational answer. Okay, next example, again, getting it in the right form, adding 7x to both sides and adding 9 to both sides. Gives me the quadratic equation negative 6x squared plus 7x plus 3 equals 0. Multiplying through by a -1, 6x squared minus 7x minus 3 equals 0. Evaluating that discriminant, b squared minus 4 times a times c. All right, -7 squared is 49. 4 times 6 is 24, and 24 times 3, I'm grabbing my calculator for that one, is 72. And that's going to be minus a -72, or just plus 72, right? Minus a negative makes positive. If I add those two numbers together, I get 121. That's a positive number, so I'm going to get two real solutions. And I can take the square root of 121, so I am going to get rational answers. So two rational, real solutions. All right, the next example, again, getting it in the right form. I'm going to subtract 10x and subtract 5 from both sides. So I would have 2x squared minus 10x minus 5 equals 0. Evaluating the discriminant, b squared minus 4 times a times c. All right, 10 squared, negative 10 squared rather, is 100. Four times 2 is 8. 8 times 5 is 40. A negative times a negative is going to give me a positive there. So 100 plus 40 is going to give me 140 as the value of my discriminant. That's a positive answer. I'm going to get two real solutions. However, I cannot take the square root of 140. It's not a perfect square, so I am going to have irrational solutions there, ones that involve a square root symbol. All right, last two examples for the discriminant. This number 5 is not in the right form yet, so to get it in the right form,